The motorway that will link Port Elizabeth with Cape Town crosses here, at the border of a wildflower reserve, the Van Stadens River Gorge. Kilometres of curve, steep grades and discomforts and hazards of the present road over the pass are eliminated by a new bridge with a deck 360 metres long by 26 metres wide. The main feature of the bridge is a single great reinforced concrete arch, 125 metres above the gorge, an arch 15 metres wide and 200 metres in span. Convinced that for an arch of this size the conventional methods of construction were inadequate and even dangerous, we decided to build it this way. We build the approach spans, prepare the pre-stressed anchorages in the rock, build the arch foundations and erect the supporting towers. On a pipe scaffolding, we assemble the moving carriages which, during the pouring and curing stages, will support the future cantilevered arch sections. On the carriages, we build the initial arch section. We erect the pendulum portals, and after connecting and stretching the first anchoring and suspension cables, we dismantle the scaffolding and make the first move with the carriages. With the building on the carriages of the first two sections, the construction of the arch by suspended cantilevered sections begins. Having moved the carriages, we build the number 2 sections, adjusting the tension of the suspension and anchoring cables. We shift the carriages and build the number 3 sections, and so on with the number 4, 5, 6, etc. We modify the tension and number of the suspension cables according to our operation schedule, so that at any instant and under any possible condition of load, wind and sun exposure of the cables, the completed arch portion will be stressed within precise limits. With this continuous adjustment of balances, we get down to building the number 13 cantilevered sections. Now we get to the crown section, which is built. The arch is completed. Then we remove the cables and the pendulum portals. Finally, we build the deck on top of the arch. We dismantle the supporting towers and the carriages. The bridge is completed. Of the total 7,000 metric ton weight of the arch, excluding foundations, 5,000 are made up of suspended cantilevered sections, built with materials and equipment typical of pre-stressed concrete. Thus, the pre-stressed technique, which seemed to have just about decreed the end of arches, has now confirmed its constructional soundness for arches of a very long span. This is the carriage or movable platform for the construction of arch sections. For various reasons, it was complicated to have it move on wheels. This is how we solved the problem of moving the carriage from one section built to the next to be built. Pendular movement obtained by gravity releasing the tail winches. Vertical movement obtained by lifting with the head winches, helped by electro-hydraulic jacks. Pendular movement obtained by a force tangent to the arch, applied by electro-hydraulic jacks. Upward movement perpendicular to the arch, obtained by means of the winches, helped by electro-hydraulic jacks. Finally, micro-adjustment of the inclination obtained by means of electro-hydraulic jacks acting on the tail wheels at the introducts of the arch. This is the mock-up of the carriage built on site. In reality, each carriage, measuring 250 square meters and weighing 42 metric tons, capable of supporting a 200 metric ton arch section, is moved and positioned with millimetric accuracy. The construction cycle of each arch section begins with the assembling on the carriage of the reinforcing steel partially prefabricated on site.
Step down, 20, then stop, down, 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 50, 40, 30, 20, piano, piano, slowly, slowly, down, 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 stop.
Then, the formwork, also prefabricated on site, is positioned. And finally, concrete is poured. 1,150 cubic meters in the arch foundations and 2,700 in the arch itself.
Piano, piano, slowly, slowly, down, 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 stop.
The cables, an essential part of the arch construction method, are installed and removed by means of this small cableway, thus avoiding the need for scaffolding. The total length of cables handled in the various operations, removal and reinstallation after retrieval, equals 43 kilometers. The catenary of the cables is reduced, and the last sleeve is connected. Of the 3,300 sleeves used, only one was found defective. This is one of the 4,300 cable stretching operations carried out. There were 900 dynamometric checks and 600 arch deformation line checks. The two suspended half arches are now about to meet at the crown. A catwalk is laid on top of the two carriages to allow the two teams to meet. Under severe conditions, while the arch was being built, the wind often blew at more than 60 kilometers an hour, with gusts of over 130 kilometers an hour. These men have applied advanced techniques, some without precedent in engineering history, with skill, intelligent courage, and a sense of individual and team responsibility. The result is a perfect arch and no injury or damage. 176 days after the beginning of the construction of the first cantilevered arch section, the 8th of September 1970, the arch is completed.
Wonderful.